A quantum history outline. 1900. Max Planck proposes the idea of quantized energy in order to explain the observed spectrum of black body radiation. 1905. Albert Einstein uses Planck's idea of quantized energy to explain the photoelectric effect, for which he is awarded the Nobel Prize in Physics in 1921. 1913. Niels Bohr proposes his model of the atom, which is based on the idea of quantized energy levels. 1924. Louis de Broglie suggests that particles such as electrons can exhibit wave-like properties, leading to the development of wave-particle duality. 1925. Werner Heisenberg proposes his uncertainty principle, which states that the position and momentum of a particle cannot be measured with infinite precision at the same time. 1926. Erwin Schrödinger develops his equation for wave mechanics, which describes the behavior of particles on a quantum level. 1927. Paul Dirac combines Schrödinger's equation with special relativity to develop his theory of quantum electrodynamics. 1932. James Chadwick discovers the neutron, leading to the development of the theory of nuclear structure. 1935. Enrico Fermi proposes his theory of beta decay, which explains the emission of electrons from certain types of radioactive nuclei. 1947. Willis Lamb and R.C. Rutherford measure the Lamb shift, which is a small energy difference between two energy levels in the hydrogen atom that cannot be explained by classical physics. 1964. Murray Gell-Mann and George Zweig propose the theory of quarks, which explains the structure of hadrons, such as protons and neutrons, as being composed of more fundamental particles called quarks. 1974. Abdus Salam, Sheldon Glashow and Steven Weinberg propose the electroweak theory, which unifies the electromagnetic and weak nuclear forces. 1984. Carlo Rubbia and Simon van der Meer receive the Nobel Prize in Physics for their discovery of the W and Z bosons, which provide evidence for the electroweak theory. 1995. The first evidence for the existence of the Higgs boson is announced, providing further confirmation of the standard model of particle physics, which is a theory that describes the fundamental building blocks of matter and the forces that govern their interactions. The following sections will provide brief biographies of famous quantum theorists and their contributions. Max Planck was a German physicist who is widely regarded as the founder of quantum theory. His contributions to this field of physics were groundbreaking and have had a lasting impact on our understanding of the nature of the universe. Planck was born in Kiel, Germany in 1858, and he received his PhD in physics from the University of Munich in 1879. After completing his studies, he became a professor at the University of Berlin, where he spent the majority of his career. One of Planck's most significant contributions to quantum theory came in 1900, when he proposed a new model for the way that energy is emitted and absorbed by objects. Prior to this, the prevailing theory was that energy was emitted and absorbed in a continuous manner, like a smooth wave. However, Planck's model proposed that energy was actually emitted and absorbed in small discrete packets, or quanta. This revolutionary idea was the first step towards the development of quantum mechanics, which would later explain the behavior of subatomic particles. In addition to his work on quantum theory, Planck also made important contributions to the field of thermodynamics. He developed the concept of entropy, which is a measure of the degree of disorder in a system. This concept is now an important part of statistical mechanics, which is the branch of physics that deals with the behavior of large systems composed of many particles. Planck received numerous accolades for his work, including the Nobel Prize in Physics in 1918. His contributions to quantum theory and thermodynamics have had a profound impact on our understanding of the fundamental nature of the universe, and his work continues to be studied and revered by scientists and researchers around the world. In conclusion, Max Planck was a pioneering physicist whose contributions to quantum theory and thermodynamics have had a lasting impact on our understanding of the universe. His ideas and discoveries have laid the foundation for many of the advances that have been made in these fields in the years since his work, and his legacy continues to be recognized and celebrated by scientists around the world.